Good afternoon, ladies of calculus. Welcome to room 15, where?
Learning never ends.
Learning never ends. Even when Elizabeth, even when Kinsey are gone. Still, we got to do this. So what I want you to do is use our system to go ahead and work out problem 5. And we'll talk about it. This is one of the kind of a standard type of problem, a different type of equation than what we've used so far. And we'll talk about that in 4 minutes. Kaylee, are you doing number 5? Carmen, are you doing number 5? Looks like it. Emma, you're working on number 5? Ladies, I'm going to be right back. Okay, anybody have an answer to this yet?
We got the W.
You got the W?
I always forget how to write. Now it's like VR over DC. And
Okay. So are we stuck? Karina, you have this one? Still working on it? Let me give it another couple of minutes. Carmen, what about you? I'll give you a couple of minutes. By the equation is going to be what?
area equals length times width.
Area equals length times width, exactly. So the width is increasing at a rate of 2 centimeters per second squared, per second. The length is increasing at a rate of 3 centimeters per second. So your answer, what do you know about your answer? Okay, let's think about that. Okay. So basically, this one, we have find area at what rate? So you want when we have
Width equals 4 and length equals 5 centimeters.
given
Width is 2 centimeters per second. And DL over DT is 3.
and our equation is going to be area equals length W, right?
Yep.
So now we're going to take the derivative of that, which is dA dt equals what? Equals dL dt times W plus dW dt, the LDT, excuse me, DL. Yeah, dL dt times W. Yes, you got it right.
I thought you multiplied on the
dW dt L.
You have a plus. How does all multiply? Because the equation just has length times width.
Yeah, and you are, what it is, remember our product rule of derivatives, remember that? Product rule is, if you have the derivative of u times v, it's going to be equal to uv prime plus vu prime. Product rule, okay? So we're going to take, it's going to be the derivative of this times this plus the derivative of this times this. Product rule. So now we can just plug in. So the ADT is going to be equal to dL dt, which is 3, times our width, which is 4, plus dW dt, which is 2,
Comes back.
times our length, which is 5. So we're going to get
12,
plus 10. So dAdt equals
22.
equals 22. So 22 centimeters
per second
squared. Square centimeter. Anybody get that as an answer? Emma, you got it?
Well, I just got the equation thing, but I've had the minus of them off the plus side
Okay.
and solid, so.
Oh, okay, so you just didn't plug in your numbers. You didn't quite fit. All right. Now this is one, when I asked that question earlier, what should you notice about your answer? Well, the answer I was looking for you is to be a positive answer. This is one that's really, that I have a hard time understanding what's going on until I backtrack and consider our rules of calculus. And the reason for that is because I look at, just kind of my intuition tells me, well, if my width is increasing at this rate and my length is increasing at 3, well, the area is obviously going to be increased by just multiplying those together, right?
Yep.
So 6 centimeters squared per second is kind of what I intuitively would think, but it's not that, because we have to consider what makes a difference is how, at that time, how large the actual width and length are for that rectangle. So that's why that is the case. So that's another type of standard problem. And again, and to me, once you've done that, this really should be an easy type of problem. Do you have questions about that? Okay. Let's see here. And let's look at this one. Okay, we have the fish tank problem. The water pours into a fish tank at this rate. How fast is the water level rising? The base of the tank is a rectangle of this size. What is that going to be? And then, okay, then we'll go ahead and look at change variables, the next one. What did you get for this one? No one? Yeah. Anybody have an answer for this yet?
I got 1/2.
1/2 feet per minute.
Yes.
Okay, anybody else? How did you do it?
Going through plug that in as the volume of the microphone.
Yeah, so basically, we're going to find dHdt, right? When, well, here's a curious thing. It really doesn't have any when, does it?
No.
There's no particular time. And what are we given? We're given dV dt equals 3 feet. And also your base is equal to 6 feet squared, right? And what's our equation going to be? Volume equals 6h, right? So 6h. So let's find the derivative of this. So we get dV dt. And what's our derivative of this? It's going to be 6
Yeah.
dH dt. dH dt. Let me write that down. So can we plug in now? Yeah, so let's plug in dV. So 3 equals 6 dH dt. And if we divide by 6, dH dt equals 1/2, right? Feet per minute.
Perfect.
So is that the way you did it? Okay. Yeah, that's a good way. Pretty simple. And this is a
I
problem.
didn't multiply them for the base when you did originally. Like I left it, I put the length was 2 and the width was 3, but.
Oh, okay. Okay, so you
multiplied them
plugged it in
with that.
afterwards.
Yeah.
Okay, that's good. That's a smart way to do it, really. But in this case, we're not given a when particularly, are we? And here's another thing too, is it really possible to do this problem without calculus?
Yeah.
Yeah, it is, because you can see the rate. You can see the rate is going to be a linear type of situation. But I like working this out as a calculus problem, just because it can be done. So I'd consider this one to be probably easier than your average related rates problem, but it is related rates. Okay, now we're going to be advanced to our next note card, which is one that looks at other increased level of complexity. And so we have an inverted cone, has a height of 9 centimeters, a diameter of 6 centimeters, and it's leaking water at this rate. So at 1 centimeter cubed per minute, find the rate at which the water level is dropping when h equals 3 centimeters. So what I want you to do for this one is find all the things about it you can. And this is a little bit trickier than the other one, so I want you to go ahead and work out the parameters. And then if you're not getting this, we'll talk about how to solve. And this one right here is a standard type of calculus related rates problem, is what it is. And they give you the volume of a cone too. They give you that formula. So take a few minutes and put this together, and we'll go over it. So basically it's the equation of a cylinder, except the cone of a cylinder is 1/3 the volume of a cylinder with the same base and height, 1/3 of the volume.
What about the other one? R? That's the thing, so the radius is half of the diameter, so your R, you're going to have diameter. Your radius. So you should just put R equals 3 instead of D equals 2. What? Well, it's where of which the water is coming out. So deep.
So we found it in this. You wrote it with a blanket.
Two. It was
So 2/3. 2/3 pile. I don't know.
Okay, did anybody get in place on this one yet?
We were trying to find the derivative of that, and we got confused.
Yeah, so the one thing you have is you got a situation where you have two variables here, and you're basically what you have is you got a cone-shaped tank, essentially, and it comes down like this, and you want to get at a certain height, that height being 3 centimeters. So that's 3 centimeters right here. At that height, you have the overall height of this is 9 centimeters. And your cone is leaking here at rate of, let's say, dVdt is going to be equal to -1 centimeters cubed per minute. So that's a leak, and it's height of 9 and diameter is 4, which means the radius is,
Is it what?
radius is going to be,
Diameter is 6, not 4.
the radius is going to be
Right?
3. So 9 centimeters is your height. So you're going to find you're trying to find the rate water level, so it's going to be dH dt. And what do you know about, what is one thing you know about dH dt? When h equals 3,
Yeah.
and what you're given dA dt equals -1, it has to be centimeters cubed per minute. And you're also given the cone's dimensions. So the height, overall height is 9 and diameter is 6, or radius is 3. And our equation is going to be this one, which is volume equals 1/3 pi r squared h.
I have that right there.
Okay, what are you gonna have to do with this thing?
Derivative.
Okay, but even before that, you have two variables in here, right? And so we want to find dH dt, but what about, we have this r in here, so what do we have to do? Or what would help us? So what would happen is we know that our height is going to be 3 times like 9 is going to be equal to 3 times our radius, right? So our height is going to be 3 times our radius, because that's the dimension of the cone. So 9 times, so our height, let me put it this way, our height is going to be equal to 3 times our radius, is that right? And so let's go ahead, and if we plug in this for h, so h equals 3 times radius, we can plug in that here. So what that's going to be equal is 1/3 pi, and since actually r is going to be equal to h over 3. So we have h over 3 squared times h. So what is this going to be over here? Volume is going to be, what's 3 squared? 9 times 3, 27. So volume is going to equal 1/27 pi, and we're going to have h to the 3rd power, and that's it.
Yep.
And so now, to take the derivative, what's that going to be? dV dt is equal to 3 times that. So that's going to be 1/9 pi h squared, then dH dt. And now we can plug in for h, can't we?
Yeah.
So what's h going to be?
9.
No, when h equals 3. So h squared is 9, right? So dV dt, which is -1, equals 1/9 pi, and then we have 3 squared times dH dt. So what is this going to be here? Well, 9 over 9 cancel, divide, so dH dt is going to be -1 over pi, what is it, feet per second, or centimeters per second, or per minute? Per minute. So that's what that's going to be, -1 over pi centimeters per minute. So we're going to go ahead and pick up on this tomorrow and work a couple more of these. And we're gonna get into our next note card here very shortly. Yeah, we'll do a couple of these.